Okay, I'll move this session on towards invertebrates, finally. And in marine invertebrates, their most important skeletal mineralogies are calcitic and aragonitic taxa. Now, in inorganic experiments, it has been shown that calcite develops or precipitates in colder temperatures, aragonite in high temperatures. So the logical question is, does that also affect animals? And that has been demonstrated, for example, for the blue mussel, Mycos. They have an outer calcitic shell layer, and the inner layer is aragonitic. For them, the colder the water is in which they grow, the more calcite they use, the thicker the calcitic shell layer is, and vice versa, with the aragonite being predominant in warmer water. It seems to be a metabolical advantage to secrete calcite in colder water. So I wondered, well, since we have this latitudinal temperature gradient, do we have also a latitudinal gradient in aragonite calcite? To answer this question, I turned to the paleobiology database because I wanted to know it throughout the Phanerozoic, and I separated the data of marine calcifiers occurrences by using the paleolatitude. So I have two groups. One of them is tropical, well, rather broad, 35 south to 35 north, and compare them with higher latitude occurrences. I'm calculating their success as the summed common species occurrence rate, which means basically how widespread, how abundant are the taxa. And I calculate the aragonite success relative to all calcifiers. The results I show you here. On the y-axis, we have the success of aragonitic taxa. Low values mean, well, low success. And here, high values mean high success of aragonitic taxa in the tropics in red, and compare that with high latitudes, mid to high latitudes in blue. There is basically no pattern. And this puzzled me because there are so many examples from individual groups which seem to show us somewhat of a gradient in modern days. So I thought maybe the reason is in the paleoclimate, because for much of Earth history, the climate was more even across latitudes. There was not such a strong latitudinal temperature gradient. So I separated out ice house intervals in the gray bars, where we think that the temperature gradient was similarly strong as today. And just looking at them, here, late Ordovician to early Silurian, not much still. In the late Carboniferous, it's the only time where there's really aragonitic taxa are more successful in the tropics. But then again, as we move on, for example, in the early Cretaceous, or especially today, there is really not much of a big difference. And I think that I will need to use either specific groups, for example, look just into bivalves and see if I can find a pattern. So I've started doing that with modern data. But again, it doesn't seem that latitude controls skeletal mineralogy. So unfortunately, my title is a bit misleading. There's not actually much of a trend there. Thank you.